Okay, this is where we are. I think everybody knows that bit. Whoops, wrong. I have a new clicker, so a laser pointer, up and down buttons, and something that I don't know what it does, so I'm a little nervous about that one. What's that? It's either that, it's the eject pod. I don't quite know. Here's what we're talking about: Solr aggregation, or streaming aggregation in Solr. It's new stuff. This is bleeding edge, and I'm pretty sure this will all be available electronically afterwards to all attendees. So you know, if you take pictures, go ahead. I don't care, but you can get at this later. Who am I? I'm this guy. Erick Erickson, all this kind of stuff. I detest reading slides to people. I assume everybody here can read, so I will be decorating these things rather than reading them individually. The one I do want to call out, though, is that I'm not this guy. I don't, if you search my name, the exact spelling, you'll discover a person whose politics are not mine. I'll put it that way. And if you don't know about the XKCD cartoon strip, you really should, because this describes all technical persons' lives. We sit here, we have a little metal rectangle, we press buttons, and the pattern of lights change. That's my life. Okay, lots of stuff to do. The agenda here. This is a high-level approach to streaming, introduction to streaming aggregation, and the things built on top of it. It's really bleeding edge stuff. It's putting us in a place where to be able to do things with Solr that we haven't really been able to do before. There's a lot of stuff here, so I'm going to be talking about it at a fairly surface layer. Where's Joel? Mr. Bernstein, stand up, please. Joel Bernstein has done most of the coding. He's going to be giving a deeper level talk afterwards, and he would love any help that anybody can give for hardening it up, because he's doing this on his own. He's the primary author of most of this stuff. Dennis Gove, sorry, you stand up. Dennis has built some stuff on top of this already called streaming expressions, which we're going to talk about. That's this other point here. And any deep level questions, you nail Joel with, because I probably don't know the answer. I have a sample database. I'm not going to go into like running live samples because it just never works for me on a presentation. But it's from a mortgage database, publicly available stuff. And I'm really going to assume some familiarity with Solr. I'll talk a little bit about what doc values really are, but the rest of it, you should know about fields, you should know about documents, you should know about all that kind of stuff. And if you don't, please stay here, but you might be a little bit lost. So the question is, what does streaming aggregation bring to the table? And what it brings, in particular, is that Solr has never dealt with returning very large result sets and working with them. And the reason for that mostly is that at this point right here, to return an FL list when you do a query of Solr, you say FL equals field A, field B, field C. That's the stored data. The stored data gets returned to you from disk. And the minimum decompression block is 16K. So if I want to work with export 1 million results, then I have to decompress 1 million results to return data to work with. And that has never been performant, and it won't be performant in the future. We haven't even been able to do deep paging until fairly recently, until Chris Hofstadter put in the cursor mark stuff. And deep paging is the problem where somebody, usually a bot, is going through and saying, give me page 2, page 3, page million, page 10 million. And that has also suffered. We haven't really even been able to do that very well until quite recently. And even when you can efficiently get the 10 millionth page, you still have to process data, to do something with it, you still have to run out to disk and decompress it. So it just kind of shifts the issue of pulling out 10 million documents and putting them all in a huge packet and mailing them back down to your client at once, with doing that over some period of time. You're still doing all the work. Streaming aggregation gets around all of that. And you just can't fit some of this stuff in memory. Very recently, sorry, quick war story, I can't help myself. A few years ago, a billion document corpus was something we had to spend a lot of time helping people set up and helping all the replication, master slave, and the sharding, and the custom routing, and all that sort of thing. And quite, in the not too distant past, we said, 1 billion documents, what the heck, I'll spin that up for you tomorrow, don't worry about it. Concomitant with that, though, has been the problem that people want to do something with all those billion documents. Streaming aggregation is giving us a way to actually deal with that kind of result set. Not sub-second, batch-oriented, kind of mostly at this time. I'm waiting for Joel to grimace back there and say, you got it wrong. But it's going to let us deal with those kinds of data sets without breaking the bank, without taking forever. So how do we do that? Well, it's built on something that came into the 410 time frame called exports. And basically what it does is it exports a tuple. Now don't get hung up on what a tuple is. It's just a Solr document as far as processing is concerned. It's the field list, the FL list that you specify in the query, comes back, it's a map, key value pairs, really not a complex, complex thing at all. This is the big restriction at this point. It can only export primitive types. Those are numerics, those are string fields. It explicitly does not return, and doc values do not deal with analyzed field types at this point. And it won't. The reason that restriction is important is because that's how you get up to the scale that this stuff can operate at. You don't have to go to disk anymore to export doc values. They're memory structure, they're low-level Lucene structure, they're mem-mapped, all that good kind of stuff. So I can now start doing things like exporting, and the design goal is like 400,000 rows per second from 8 per second per node, or in essence per shard, which you cannot do with stored fields at all. There is some way cool stuff in there that the work that you do with those can now be distributed amongst all your Solr nodes. And some of that can happen automatically, particularly in the parallel SQL world. Now, Joel has waved his hands a little bit at me when we talked about this at one point, but said, there's no reason we can't process tens of millions of rows a second given sufficient hardware, given sufficient whatever. And the aggregation part of this is important because now I can do things with that. I can compute stats and do analytics over that kind of volume of rows. So it really does open up Solr in a way that that we haven't been able to do so far. And I will apologize in advance because when I start spinning off and talking about what this reminds me of, I sometimes anticipate slides, but I'll skip over those if I find myself doing those. Again, it's really important to understand that doc values are the things that can be specified in the FL list for streaming expressions, streaming aggregation, streaming anything. Primitive types, TNs, T-longs, that sort of thing are also included in primitive types, so don't worry about that end. These are per field in the schema. So it is not necessary that the entire Solr document be doc values. It's just that the field list that you specify has to be doc values. So I can have free text in there, I can have analyzed text, I can have whatever, I just can't export it for streaming aggregation purposes. So what the short form rule is that only the Solr.text field or Solr.text field are things that cannot be doc values. Let's see. And this is the kind of part that geeks people a lot. And by the way, my explicit goal in giving this talk is, since this is so bleeding edge and very few people know about it, I'm trying to get at least enough curiosity for the capabilities and what this will allow to be able to have some people go out and give it a spin, and we'll start hammering at it, making it much more as robust as possible, et cetera, et cetera, et cetera. But I can now do SQL stuff. So I can ask questions like, and these agency code, actually I've got this in more detail a little bit later, but I can do a select statement, certain aggregations that are supported by SQL. I can ask for, this is a collection in this case. And I can do some interesting things like, this is the this Solr query now. So I can now ask questions that I can't ask of a database very easily. And I can do this kind of having thing, which is very hard to do currently in Solr. He's just smirking at me right now. Going to go out and test it tomorrow? Okay. And group by, order by, kinds of things you'd rather expect. Oh, and it's not going to be a full ANSI SQL at this point. Capabilities are being added as rapidly as we can and as need occurs. So I can, outside of the parallel SQL world, I can do arbitrary operations on this complete 10 million rows or something like that. And by arbitrary, one of the actually difficult things to calculate for Solr is the median value, because you can't approximate it. You have to return all the values to know which one actually fell in the middle. So I can now think about doing things like that in ways that I couldn't. You can parallel parallelize the processing. And Joel will talk a lot about this in the meeting afterwards. So this is partly what that talk is titled. But I can use my Solr nodes out there in kind of a map-reduce way and have them divide and conquer the operations that I need to have happen. Interestingly, for the non-SQL case, the non-parallel SQL case, those nodes don't even have to be part of my collection. So I can have conceptually a series of Solr worker nodes out there that don't have any indexes, that don't have any collections hosted on them, and I can have them take over parts of my processing for this thing without having to do any like distributed management work. You just specify the number of workers. It's in the calls, and I have some examples of that in a bit. This is the other thing that's very interesting, is that this all works on the idea of sorted streams. So I will sort my streams coming back from whatever my series of connections are by some value. So rather than having to keep all of that stuff in memory at once, I can skip along these streams, processing the things that are the same value. When I fall off the end of that value, I can do what I want to with that thing, throw it away, and go on to the next one. So my memory footprint on my client can be tiny still to process tens or 20s or hundreds of millions of unique values, which gets around another constraint in Solr, where to do like faceting and that sort of thing in Solr itself, you have to collect all of that on the server, distill it, and send it back. By streaming it back in a sorted order, I don't have to have that kind of memory footprint. And I said the design rate was 400,000 rows per second per node. And node in this case, think of it as a shard. In a completely untuned situation, in an early version of this, I got 200,000 rows a second without looking at the network, without looking at my query, without looking at anything at all. And I replaced, I don't want to brag because it was somebody else did all the work, but it replaced about 6 programmer months worth of work in low-level Lucene trying to do the same thing that they couldn't put in a distributed environment. So you can do some things that you just can't do otherwise. Let's see, 142, okay. Streaming aggregation under the covers is the glue. So as you all know, I mean, Solr is really built for turning the top 20, 30, 40 documents. We talked a little bit about the fact that you have to decompress the field list to return. And a lot of that is great. I mean, it's what it's built for. And the scale that we've come to recently with the billions of documents things has made that model kind of hard to push to some analytics sort of applications. The analytics side, so we've kind of layered some things on top of Solr to try and make it do analytics kind of stuff. And that's been a more or less awkward fit. You've seen Hausman put together the stuff about hanging stats off of pivot faceting. Pivot faceting came in as a way to try and subcategorize and do some kinds of operations, sometimes aggregations on n-dimensional field set things. Problem with all of that is it still requires all this sorting on the Solr server. And we're really running into the limits of trying to scale that to these huge collections that we're working with at this point. And this last point is that all of this is really kind of coming to a head, I think, over the last couple of years, because we're now dealing with data sets that we couldn't deal with even 3 years ago. Before the advent of Solr Cloud, I mean, a lot of this didn't really apply because we couldn't get up into the $10 billion, $10 billion? Sign me up for 1%. The 10 billion document kinds of collections without an awful lot of work. Okay, so we really have 3 modes to streaming aggregation. There's the raw streaming aggregation. I'll show you an example of this in a minute. It's Solr J. Streaming expressions are written on top of streaming aggregation as a way to get at this information without having to do it in Solr J. So there's now an HTTP connection that does some of these aggregations for you and lets you just process the HTTP coming back. And that's what Dennis is working on. The parallel SQL bit, we can do a series of SQL operations on very, very large result sets. And currently, I'm cheating a little bit here, okay, but currently my opinion, and Joel may have other, some insights to where this is going, is that streaming aggregation sweet spot is really kind of batch operations. I don't know at this point, it's so new that I haven't really seen it exercised hard in high query per second operations. So I'm not sure you're going to support 400 queries per second on a $20 billion document collection and have that be have that scale to that level at that QPS rate. That said, an awful lot of things that people want to do in the analytics world are not high response, high volume, or quick response, high volume operations, and that's what this really opens up. And a quick, okay, I'll wait for a second for this next one. And so the question is, okay, so you're making Solr be able to do this SQL stuff, but don't we have these tools that are built already to do SQL stuff? And the answer is, yeah, we do. And if that's the best tool for your particular application, feel free. Absolutely, use the right tool. But RDBMs, I can't tell you how much I respect the work that's gone into them. A lot of really brilliant people have done a lot of great work to be able to make them operate the way they do. But they're really lousy search engines. I'm sorry. So this allows you to marry the search capability of Solr with SQL-like operations in a way that would be a much longer, more difficult process. And my example is, of course, my favorite. My favorite is my name. Those are all phonetic equivalents of my name. And it's, how do you make a database? Go ahead and find the average for all loans given to somebody whose name sounds like Eric. I can set up a very specific situation to do that. I could index my phonetic equivalent as a column in my database and make that part of my schema, but then I can't switch it. I have to go redo my database in order to do the next thing. This allows absolutely arbitrary Solr queries to be treated with certain SQL operations. And that's this last point. You really do keep in mind when going through all this stuff that the SQL or the Solr query is completely arbitrary. Whatever you want to put in there, the entire power of Solr is behind these things. I don't know. I was talking, this is kind of a panic slide because I knew somebody was going to ask, so I pinned Tim Potter down. Tim, you around? No. Oh, good. I can say anything I want to, and he won't contradict me. And quite frankly, this is all new. We're trying to understand what the limits and what the sweet spots for, like the Spark Solr connector that Tim Potter wrote. What's the sweet spot for that? What's the right problem for straight streaming aggregation? What's the right problem for the parallel SQL operations? And my intuition at this point is they're all going to be complementary as time passes. There'll be a series of problems that, I was in fact talking to Tim yesterday, and he said, oh, wow, I could use the streaming aggregation stuff as the way I import stuff into the Spark Solr connection rather than doing what happens now, which is going back and returning all those field lists and decompressing all those documents. So I utterly guarantee in the fairly near future, Tim's going to put a filter on top of the Spark Solr stuff that says, if all the fields you ask for happen to be doc values fields, why don't we import them at 400,000 rows a second rather than whatever it takes to actually decompress them and move them back currently. The differentiator, and I think an important differentiator, is that the whole streaming aggregation and parallel SQL operations don't require anything except Solr installed. So if you already have an infrastructure that has Spark on it, that has, or Hadoop or whatever, you can then integrate those things. Contrary-wise, if you don't have all of that, you don't need it to use the parallel SQL operations. And I think that's going to be kind of a major deciding factor for a number of people, whether it's, whether they want to add yet another tool to their stack. And why not just use Solr? Well, we talked about this. But, and frankly, what I would do is, take some time and try and figure out what it is about Solr that doesn't satisfy your use case before jumping into the streaming aggregation stuff. I'm a great advocate of not using the same hammer just because I discovered it. It's kind of like a religious convert, right? I'll go out and convince everybody else that I found the greatest thing in the world, and they don't need it. So if you don't need this tool, don't use it. Be aware that it's there, though, because it is way cool. So let's stop all of that stuff and get into some more details here. Okay, not too bad. About halfway through, I think. So I've got a simple example, and generally, almost all computer problems or computer science problems at root are very simple. You do a simple thing. I want to get a bunch of rows, and I want to do something with them. And that something is limited by, frankly, by what you can program in Java. So there's the sky's the limit there. Another interesting and subtle point is these streams are all independent of each other. I open a connection to a stream, That stream is targeted at a collection somewhere. I don't care where that collection is. I don't care if that has anything to do with the other stream that I'm reading at the same time. I don't care if that second stream is in a, coming from a Solr in Tokyo. I mean, I care a little bit because of transmission lag, but that's about the only reason I care. But now I can do things with those streams coming back, and in particular, I can now do cross-collection joins in an efficient and fast manner at 400,000 rows a second. It opens up some possibilities there that I think that people have been asking for a long time. There's a couple of JIRAs out there about cross-collection joins, but doing cross-collection joins across different data centers is kind of, well, we don't want to deal with that because it's way too complicated at this point. We can do that in this scenario. I don't know where it's going. Well, pardon me. You absolutely have to be sorting your return set. I overstated the case. By and large, you will be sorting the return streams in order to be able to process them in kind of on a skip list basis, so that you're not reading one stream entirely into memory and then doing something with it and reading the entire stream into memory and modifying it. You want to keep that memory footprint small. And that's this point. I think this would be cool. So I say you process things of a kind in these sorted streams and you're done with them and you do something with them. That something is write it to a file. I think it'd be kind of cool to write an R connector, for instance, to dump it straight into some sort of R and analytics process. No reason you can't. So am I convincing you all that I'm kind of geeked by this whole thing? I think it'd be great. So let's talk about some sample data. My son-in-law, of all people, is doing some research, and he was able to scrape 200 million mortgages off of a publicly available site. Has these kinds of things: year, loan amount, agency, things like that, reason for loan, reason for denial. I want to emphasize in this example that there's no personal data in this, so I synthesized some people's names and attached to these things, so I'm not violating any privacy rules here. But you see where some of this stuff can go, because you have things like reason for loan, reason for denial. Some of the fields I didn't put in here is, of course, they gather statistics on race, ethnicity, sex, marital status, all that sort of thing. So I can now slice and dice this information, answering a whole series of questions that I might want to answer about who got denied, who got accepted, what region. You can see where that would go almost immediately. What's the average? Well, actually, you'll see one of my queries here in a second. So here's the basic pattern. We create a query, we feed it to a stream, we process the tuples. Ask a question, get stuff back, do something with it. And a tuple, as I mentioned, is just a simple wrapper. Think of it as a Solr document. If you're familiar with Solr already, you get the results list back for each document in the list, get field X, get field Y. Same interface, don't have to learn anything new there. You see I'm repeating this repeatedly, that they have to be doc values because that's an important point. We talked about and this is the reason. Once you understand that getting the stored fields is the expensive bit of returning most Solr documents, then this whole doc values restriction just kind of makes sense, falls right into place. Here's what the code looks like. So I got a 2-shard collection. In this case, my local machine. I want just the average of mortgages by agency. And in this particular case, again, no tuning whatsoever. I brought back 217 million documents in the data set. In this query, I had 335,000 results, and it took about 2 seconds. I probably could make this a lot faster, and this is the base, simplest possible way of doing this. This is not using the parallel processing. This is not divide and conquer. This is not using the map-reduce kinds of ways of approaching this. It's just as simple as I could possibly get. Mainly because code's always kind of, I don't know if I want to say unfortunate, but I never can really get my head around code when I'm in the audience, so I tried to make it as short as possible. This stuff up here in the blue is just setting up a query. Standard Solr, nothing magic about this whatsoever. I say my query is the phonetic name of Erick, and this is important. This is built on export, so it has to go through the export handler at this juncture. This stuff down here is just setting up my stream, telling it I want to go ZK host to what you'd imagine. This is my collection. My params go down there, and I open the stream. Nothing terribly It's not very much code for this. I broke this up a little bit, and this is the basic loop. You know, while we read a tuple, if there's a special EOF tuple that you can print, it has some overall statistics, has things like that in it, but that doesn't contain any document, it doesn't have any data anymore. Break, and the next slide here is, I put that in there because that's where we're doing the work. And the work isn't very much. I got a tuple, I asked for a Solr field, a document field. And I'm asking for, so I know it's a string, I got the string, I know this one happens to be a long, another Solr field, add that. And then just as long as the agency is equal, remember this is a sorted stream, so as long as the agency is the same agency that I've been working with, I just add things to the counters. And otherwise, I do something where I export that result, throw it out, and reset my counters. The emphasis here is that this is not a lot of complex code to be able to use streaming aggregation. And the other thing to take away here is that my total memory footprint for processing these 600 some rows is a long and a string. So I can just use a tiny little bit of memory to process those rows. You're smirking too. Is this something that this sounds like, maybe I should break here because it's after lunch. So does this stuff, is it making sense to people? Raise your hand if somebody can say, oh yeah, I've tried to struggle to make Solr to do something like this and it really hasn't worked very well. So, okay. Got some people trying and got some people going to go around and grab the code immediately, right? So here's another way of approaching it. Not a way, but this is, as I mentioned, this is a very simple process. I just have one, I'm going after just one, where'd it go? There we go, one collection, et cetera, et cetera. So the other things I can do is that stream, pardon me, I hope I didn't hit anybody. I don't care where it comes from. So I could have a second stream open that's actually pulling things from a completely different place. That Solr J code, quite frankly, the sum code is something you could do for a small set of 6 different agencies. You can do that with faceting just fine, or some of the current functionality. The place this becomes much more difficult is when what I want to do is do things across an n-dimensional set of parameters or set of fields. That's the thing that you can see where that code that I show you could expand that way pretty easily. So that's the arbitrary ways. I can distribute this across nodes, and I have an example of that in a second. I can use, by distributing things across the node, I can now use like all the CPU in my cluster. So I can now start using the computing power that's generally sitting there waiting for somebody else to ask a question to do some of the kind of map-reduce processing here. And finally, there are some things built in to produce zillions and zillions of buckets, or to process zillions and zillions of buckets without blowing up memory. I don't know if anybody went to Toke's presentation a little earlier this morning where he was talking, he had those graphs and all that sort of thing. Well, I think you might be interested in this sort of thing. Let's go to parallel SQL, because this is where people's eyes light up most of the time. It's really kind of arbitrary SQL within the set of supported operations. So I'm going to do the previous example, but I'm going to do it with the parallel SQL processing. Again, this is accessible from Solr J. And the current gotcha, this is where you all should beat up Joel. This is actually kind of a funny story. The SQL parser that he chose, typically the way Solr's code is developed is people check out the trunk, build it up, check it in, backport it to 5x at this point, and then release it. The problem is that Solr 6 is on Java 8 as a minimum. So the SQL parser that Joel happened to choose only compiles into Java 8. He actually found a way to a different parser that could be used in Java 7 and could be backported to the 5x code line, so that's not a real impediment. His comment to me was that if Solr 6 is delayed a long time, then maybe we'll go ahead and pull out and backport it to 5.4. There's no technical reason, it's practical at this point. So despite this, it could be put in 5x, but that's not on the roadmap quite yet. Anybody wants to volunteer, we can put it in 5x pretty quickly. So here's what parallel SQL, what parallel SQL looks like on this thing. The select is just mapped into the search. We've got those kinds of standard SQL operations and some aggregations built in, more coming. And then you can do things like this, which are hard to do in a Solr query. Say for this group that we're going to group by, I only want to return results where the sum is greater than X and the average is less than Y, et cetera, et cetera, et cetera. So this one had 612,000 rows. I only had two workers, so I had to split it up amongst some of the work up amongst both of them. And the result took less than 400 milliseconds to get back. And in this case, I liked it. What can I say? The blue stuff are just Solr fields. Again, doc values fields. Some things don't quite take fields. The collection name is mapped into the from clause. The where clause is an arbitrary Solr search. You can put filter queries in here. You can put whatever you want to. It's just shipped off to the Solr query processing. And finally, we have some group bys. These are just the things that you put there are just Solr fields. So this is what this looks like in code. Put the parameters together in blue, just like we did otherwise. And the interesting bit here is the numwork is equal to 2. Way under the covers, I can spread this load, this computation, across all of the nodes in this collection, simply by setting the numworkers equal to, say, the 50 nodes in my collection. Way under the covers, since it's being grouped and since it's being ordered, Joel, can split that stuff up into bite size, into chunks, process all of the like things via one of those nodes out there, and make use of all the computing power in my cluster without me having to program anything. I like it when other people do my work. Makes me feel really. Okay, quick other war story. I do have a minute here. I can do this. I personally felt it was a mark. I was a developer most of my life in my programmer maturity level, if you will, when I got more excited by finding somebody else's code that did what I wanted than writing it myself. You know, when I got to the point where I spent 2 hours, 3 hours a day finding the 6 lines of code that did my job instead of, and I think the reason I did that was because I tried to do the other bit where I wrote it myself so often, and then spent weeks debugging it that I decided I just didn't want to do that anymore. Anyway, we put the SQL statement. All this blue stuff is just the SQL statement. And this should look real familiar. I have a stream, open it up. While I want to do stuff, while I don't get the EOF tuple, I change this around a little bit, and I just dump it. And in this case, it's kind of interesting because the only thing that got returned to me were, oh, there it is, sorry, were 5 tuples about like this because I only had 5 agencies. So all the work got done out there, sent me back the distilled results, and I got what I wanted back. And a little bit of extra precision there that maybe isn't necessary, and that's in thousands of dollars. Another tuple, just the next agency. This is not true anymore on a 5x checkout, but if you're using a standard release 5.3, 5.2, the fields have to be lowercase. You can't mix case them. Again, that's not true if you take out a 5x, but it's like I said, this is new stuff. It's bleeding edge. We'll find some interesting things like this, and they'll be fixed. It's only in 6.0. There's a couple Solr config entries, but they're very trivial. Don't worry about it. It's just the only reason I put that in is because if you take it out of the box and you try and you install it, you just run it, it'll say, I don't understand what you mean by /SQL. Just a couple things. Don't worry about it. It's very easy. Only nodes that are hosting the collection can act as worker nodes, and I think at this point those two things are related because it has to have the SQL handler enabled. And be a little prepared to dig at this point. One of the things I would love to have come out of this particular talk, and Joel's next, is people going in, diving into this stuff, saying, I want to change the C-Wiki page, I want to add some comments, I want to make this thing, add the documentation process. At this point, it's new code, it's evolving very quickly. Be ready to dig a bit. Anything that you put in these users list that mentions this will get, I'm sure will get someone's attention in the back, right? Streaming expressions. This is a It's a query language for Solr Cloud that does some of what streaming aggregations do, but does it without any Java programming. And I better move really quickly. You can get to it through HTTP only, which is kind of the important bit, or one of the features anyway. You can do these kinds of operations. We can search, we can merge, we can group, et cetera, et cetera, et cetera. And make sure and talk to Dave about, what other cool things they can do, because I kind of had to take this one on faith. And this is what this looks like. Blue stuff is curling. Just curl some stuff. Go ahead and group surrounding a nested search operation. And what comes back is a sorted map of all the stuff that I asked for, without having to, and all this without having to do a single bit of Java programming. And again, a streaming aggregation is what this is built on, and you can produce you can process and get returned to you lots and lots and lots and lots of rows in a very short time. Okay, yep, it's broken down into maps by agency code, because that's what I told it to group by. And I'm going to zip through these next two because we're running out of time. This is very new. Expect it to be evolved. Expect enhancements to be happening right and left. The parallel SQL especially is in trunk. So this is one of the things that Joel said, I think would be cool, is to put a JDBC driver in front of this whole thing so that I can use any database visualization tool to look at my Solr store now. It's at the current developer-friendly stage, if you will. The low-level tools are in place. A lot of people are going to object to using Solr. I'm absolutely sure that more user-friendly interfaces are going to be developed around that thing. How-tos, docs. This is going to be kind of wild. He promises that you can select from one Solr collection into another Solr collection. So now you can imagine being able to decide you want to move all this data from one place to another, and then operate on that other place, slice and dice it 16 different ways, analyze it offline, whatever your imagination can do. I touched the surface of a lot of things. These exist already. And this roll-up stream is particularly, I'm curious what Toki's going to think about that and how that applies to the problem that he was trying to solve. You can merge these things together, and that's about all I'm going to say about them, because it's kind of, my mind hasn't wrapped itself fully around these guys yet. I'm sure it will just as soon as somebody says, how can I do this? And I ask Joel, how would you do this? And he'll say, use the merge stream, and then I'll be done. We haven't talked about the details of parallel execution. I think that's going to be much of what Joel's talking about next time. The mechanics of distributing things across worker nodes, it just happens. It's magic at this point. How the low-level details of how that operates, skipped them because I'm out of time in 2 minutes. I did get it right, didn't I? Okay. All how the composition possibilities, the streaming expression operations, et cetera, et cetera, et cetera. And I'm going to click through these. There's resources at the end. I do want to make one pitch, though, and that is that if you want to develop this, and especially if you want to contribute the code, at this point, given the work that a guy named Steve Rowe at Lucidworks did, and he maintains beautifully, you can set up a debug environment for Solr in about 10 minutes in IntelliJ or in Eclipse. You get the code, you execute a target, and you open the IntelliJ project file. You're done. So that stuff, if you want to dive into the code, I encourage you to let us know. We'll be happy to have any help we can get. And 1 minute to spare. Questions, and we're going to be bumped for questions very shortly, but I'll be around for the next while. Yes, sir. Hmm? Mm-hmm. Joel, can we do that? The question is, can we do the joins across collection with the parallel SQL stuff at this point? I encourage people to get behind and push any of those features that you want, because partly we're saying we think this applies to a lot of way cool places. Nothing is as powerful as somebody saying, I got a use case now. Yep. Prioritization, though. You're only one guy. Sir? Hmm? Hasn't been done yet. I can imagine a way to do that. Oh, the question is about pushing streams. So what, if I understand your question correctly, what if I have my collection here, I got a bunch of stuff, and I've registered, if you will, these streaming sorts of operations, and new data comes in. Can I get that stuff just delivered to me? Not yet. Give me a timestamp, and I can give you a cron job that'll do it for you, though. Are we officially out of time? Okay. Thank you all, and I'll be hanging around for a while.